Welcome to Money and Markets, Series 1, Lesson 1. This episode is called The Price of Time, because finance, in a deep sense, is the business of trading money across time. We will connect three threads: the time value of money, interest rates, and how present value talks to future value. That is the promise of Lesson 1. So here is a question that sounds almost too simple. $1,000 today versus the same $1,000, but you cannot touch it for a year. Which do you want? Which would you choose? Almost everyone says, today. Here is the sharper version of that instinct. Most people answer instantly, but the why? The why turns out to be one of the most important ideas in all of finance. That idea is what we are going to name in one clean phrase: the time value of money. The instinct is real. Most people say, take it today. They are right. Now we press where learning actually happens. They are right, but why? If you can answer that, the rest of this lesson becomes easy. Reason number one is the one your gut already knew. Money can work for you. Start with the same $1,000 today. Let 1 year pass at 5% a year. You do not still have $1,000. You have $1,050. So the scoreboard is blunt. Option A grows to $1,050. Option B stays at $1,000. Option A wins. And then the honest caveat: even without investing, there is a second reason, which is where we go next. Reason number two is not about banks. It is about you. We naturally prefer now. Morning coffee, a vacation, anything good. Each card hammers the same preference. Now beats later. Economists give it a serious name: preference for present consumption. And the closing line matters. This is not irrationality. It is a fundamental feature of how humans value time. Put the two reasons together, and you get one sentence you can carry for the whole series. $1 today is always worth more than $1 tomorrow. Not because the paper is different, but because of opportunity and patience and risk. So we end where the banner lands. Money has time value. We turn the corner here into section 2, into the machinery that puts a number on the cost of time. Interest rates. First idea. An interest rate is the price of time. Those last three words are doing the real work. A saver earns interest as a reward for giving up spending now. A borrower pays interest as the price for spending now with future money. Next, we zoom out to the bank as intermediary. The depositor earns 3%. The bank sits in the middle. The borrower is charged 7%. And the economics are plain. Borrow at 7, lend at 3, bank profit for percent spread. Then we add the risk lens. Rates also reflect risk. Watch the bars. 3 months at 4.5%. 1 year at 5.0. 5 years at 5.8. 30 years at 6.5. Longer horizon. More uncertainty. Higher compensation. That is the term structure idea in one glance. Section 3. Now we do the mathematics cleanly and carefully, so the pictures become formulas you can reuse. Simple interest means interest on the principal only. Notice how the word principal is highlighted. The formula is future value equals present value times 1 plus r times t. Plug in the numbers on the slide. $100,000 at 5% for 10 years. That is $100,000 principal plus $50,000 interest. So after 10 years, you are looking at $150,000 total. Straight line growth. Easy to explain. And a baseline for what comes next. Compound interest is the real magic. The headline says it plainly: you earn interest on your interest. The formula is future value equals present value times 1 plus r to the power t. That exponent is everything. The worked line uses 100,000 at 4.5% for 10 years. 100,000 plus $55,296 in interest. Then comes the sting in the banner. 4.5% compounded beats 5% simple. 5% simple is crossed out. That is the magic of compounding. We finish with three voices you have probably heard before. Einstein: compound interest is the most powerful force in the universe. Buffett: genes, America, and compound interest. Franklin: money makes money, and the money that money makes money. The chapter heading calls this the foundation of all financial mathematics. Two cards, two directions of the same idea. Future value: what will my money be worth in the future? FV equals PV times 1 plus r to the t. Present value: what is a future amount worth today? PV equals FV divided by 1 plus r to the t. Then we run the worked example exactly as written. You lend $1,000. After 2 years, you receive $1,250. What was your annual return? You solve r from FV over PV to the 1 over t power minus 1. 1250 over 1,000 raised to the 1/2 minus 1. And you land on about 11.8% per year. So we close where the summary line closes. FV equals PV times 1 plus r to the t, and PV equals FV divided by 1 plus r to the t. These two formulas really do show up in every topic from here. Then the teaser. In Lesson 2, a 25-year-old saves 10% of their $70,000 salary. And the number that lands is $3,200,000 by retirement. Not luck, not genius, just compound interest and time. Next time we pick up under that same title, Lesson 2, The Miracle of Compounding.